Hi guys, in today's video we're going to be learning how to compare fractions by finding a common denominator. Now you are going to need a little bit of background knowledge for this. One thing in particular that's very important is having a good working knowledge of equivalent fractions. So what I mean by that is, let's say we take a fraction like a quarter. It's really important that you can recognize other fractions that are equivalent to this. So for example, 2/8 if we multiply both the numerator and the denominator by 2. Or we could have 3/12 if we multiplied them by 3. Or indeed we could have 100 400ths, and all of these would be equivalent fractions. If you have a really good working knowledge of equivalent fractions, then you should find it quite easy to compare different fractions using a common denominator. Now, to start off with, I'm going to begin with an analogy that is not to do with fractions, but hopefully it'll make the next step a little bit clearer here. Let's say we have two different lines, and I'm measuring them in two different ways. I've got one that is measured in inches here, and I've got one that's measured in centimeters. Well, that makes comparing these two lines quite tricky. I've got one that's 13.5 inches and one that's 34.1 centimeters. And I need to know which one's longer. But because they're measured in different units, that makes it quite hard to compare. So what do? Well, what we can do is we can convert one of the lines, or one of the units, so that they are measured in the same unit for each one. And now it's very easy to compare them. Because they're both now in centimeters, I can see that this line here is longer because it's 34.29 centimeters instead of 34.1 centimeters. So what this tells us is that if we use the same thing to measure something, it makes it easier to compare. Now, what is it that we measure fractions in? Well, we measure it by the denominator. The denominator is, of course, the bottom number of a fraction. And that tells us how many parts that fraction is split into. So, for instance, halves or quarters. And we can tell if we have, for instance, 1/4 versus 3/4, you can immediately tell, because they're both measured in quarters, you can tell straight away that 3/4 is bigger than 1/4, for example. So let's see this in action here. Straight away, we've got two fractions here. We've got 1/2 and we've got 1/4. And I've represented these visually here. So this is not too tricky to see which fraction is bigger. You can straight away see that the bigger one is 1/2 here. But let's say we didn't have these visual accompaniments. What could we do? Well, what we could do is find a way of making the bottom numbers, the denominators, the same as each other. So, is there a way of turning 2 into 4 or 4 into 2? Well, yes there is, quite easily. I could take a half here, and if I multiply this by 2, I can turn it into quarters. Now remember our rule with equivalent fractions, whatever we do to the top, we have to do to the bottom. So I'm going to multiply this by 2 also. And what we will see is that we have 2/4 here. Now, because these are both now measured in quarters, we can compare them and we can see that 2/4 is obviously more than 1/4. What we have effectively done is we've taken this half here and we've split it into quarters. So we now have 2/4, 1, 2, where we previously just had 1/2. The fraction hasn't changed, it's still the same fraction, but it's shown in a different way that allows us to compare using a common denominator. So that's what we mean by a common denominator here. We make the denominator, the bottom number, the same so that we can compare them. Let's try it a different way here. So, again, visually, you can see straight away that this one is the bigger fraction. But how do we actually prove it mathematically? Well, we need to find a way of turning 2 into 6, effectively. So how do I turn this half into sixths? Well, what I can do is I can times it by 3. And sticking to our rule, whatever I do to the bottom, I have to do to the top. So I'm going to multiply this top number here as well, times that by 3. And what I get then is 3 sixths. Because I now have a common denominator, 6 in both cases, I can easily compare them. And I can see that 4 sixths is bigger than 3 sixths. To show this graphically, what I've done is where there was just 1 half before, I've now split it into sixths. So where there was 1 half, there are now 3 sixths. But effectively, the important thing is that I get a common denominator. So I multiply it so that the bottom number is the same in both fractions. Then I can compare like with like. Okay, so this time without the visual aid to start with. I have 1 half and I have 3 eighths. Well, what I can do is I can turn a half into eighths, can't I? I could take this and I could multiply it by 4, and therefore I'm going to take the top one and I'm going to also multiply it by 4. So where I had a half before, I should now have 4 eighths. And this makes comparing them nice and easy. Which one's bigger? Well, 4 eighths is bigger than 3 eighths. But let's see this graphically then. What's actually going on here? Well, at the bottom there is our 3 eighths. And at the top, let's first of all highlight half of it. So we've got half here. But what I've done is I've partitioned it by timesing it by 4. So I've now got 4 eighths instead of just 1 half. Still the same fraction. And you can see that 4 eighths is obviously the bigger of the two. Moving on quickly then, we've got one more example. We've got one that has tenths and another that has fifths. Well, as before, I can easily make these the same as each other. And actually I could do this a couple of different ways. I could start by making the fifths into tenths. So let's do that to start with. If I times this by 2, I'm going to get tenths. So where I had 3 fifths, I could instead have 6 tenths. However, the opposite is also true. I could actually turn these tenths into fifths as well. And I would do that by dividing by 2, which means I'll need to do the same here. I'll also need to divide by 2 there. So I would have 2 fifths. Now, no matter what way I slice it, you can still compare them very easily. So we could compare 4 tenths with 6 tenths, and we can see that 6 tenths is the bigger one. Or I could compare, let's change color here, 3 fifths with 2 fifths. And once again, we see that 3 fifths is the bigger one here. So it doesn't matter what way you compare them, you will still find the same answer. And to see this graphically, it bears true. You can see that either way you slice it, the bottom one is bigger than the top one. Now, that's all well and good when you have numbers like halves and quarters, because you can turn them into one another. But where it gets a little bit harder is when we can't immediately turn one into the other. So for instance, we have quarters and we have thirds here. Now, I can't turn 4 into 3, and I can't turn 3 into 4. So what do we do? Well, one solution is to change them both. We can turn both of these into another number, and it needs to be a number that is in both the 3 times table and the 4 times table. So you can ask yourself, what number is in the 3 times table and the 4 times table? Well, the answer would be 12. If you're unsure, you could always just do 3 times 4. Inevitably, the answer to that will always be in the 3 and the 4 times table. So if we turn both of these into twelfths, we should be able to make a common denominator. So how do we turn 4 into 12? Well, we times it by 3. So we're going to do the same up here. Times it by 3. 3 times 3, 9. So 3 quarters is really the same as 9/12. What about this bottom one then? How do I turn 3 into 12? Well, I times it by 4. So I'm going to do the same up here. Times it by 4. 2 times 4 is 8. And now it's really easy to compare them. Because they're both 12ths, I can see that 9/12 is the bigger of the two. Shown graphically, we would see it like so. So we can see the bottom one has 8/12 coloured in, whereas the top one here would have 1, 2, 3, 4, 5, 6, 7, 8, and an extra one, 9 coloured in there. So one final example here then. We have 2/3 and we have 3/5. Now again, I can't turn 3 into 5 and I can't turn 5 into 3. However, I can turn them both into another number. And an easy number to do for this would be 15, because 3 times 5 is 15. So obviously it is in both of those times tables. Now, how do I turn 3 into 15? I times it by 5. So I'm going to do the same to the top number here. Times it by 5, and I get 10/15. How do I turn 5 into 15? Well, I times it by 3. So I'm going to do the same to the top here. And I get 9/15. And now comparing them is really easy because they are both 15ths. They have a common denominator. And therefore the larger of the two is obviously 10/15. Now again, to see this graphically, effectively what we've done is we've just turned them both into 15ths like so. And you can see here that we have 10 of the squares coloured in on the top one, whereas only 9 of the sections are coloured in on the bottom one. So that's it, guys. It really is that simple. The key is you have to make the denominator, the bottom number, the same in both of the fractions. Once you've done that, you're comparing like with like. So it was like our analogy at the start where you always want to compare centimetres with centimetres. It's the same with fractions. You always want to compare halves with halves, quarters with quarters, thirds with thirds. As long as the bottom number, the denominator, is the same, then you can make a fair comparison. Cheers, guys!